Hi Sandeep, my name is Raj and today I'll be conducting your interview. Please let me know about your experiences and tell me something about yourself.
Hi, Raj. Thank you very much for giving me the opportunity for this interview. My name is Sandeep, and I've been working in data engineering domain since past 2 years. And I have been working on multiple technologies like PySpark. I have mostly worked with AWS Cloud technologies, and I have worked with the project which follows the Medallion architecture. So it is a batch data processing pipeline on which I have worked on, and that is my overall experience.
Okay, okay, good. So I'll start with the first question actually now. So as you have mentioned, I'd like to know what is the purpose of bronze, silver, and gold layers in medallion architecture. Could you please
Yes,
explain
sure.
me?
Yes, sure. In the bronze, silver, and gold layer, we keep the data. So the data which we capture from the sources, we put it in the bronze layer, and that data is completely raw. There are no data quality checks performed on it. We extract the data and put it onto a bronze layer like a folder on S3, and later we perform some data quality checks. After performing data quality checks, we write the same data to silver layer. While writing data to silver layer, we might also go for the data modeling part. So the data which is present onto the silver layer is going to follow some data quality rules, as well as it is going to have its own model. Onto the gold layer, what we do is we keep analysis ready data. Onto gold layer, we have the summary tables as well as the aggregations, so that data analysts, data scientists can directly read from that from those particular tables, and they can perform their own analysis. So from my point of view, this is the purpose of bronze, silver, and gold layer in the medallion architecture.
Hmm. Okay, I'd like to know more about the bronze layer. So tell me, why do we keep raw data in bronze layer as immutable?
If we extract the data and we keep that data onto bronze layer, the benefit of it is we don't have to extract it from the sources again and again. Let's say in the pipeline, if there is any issue which has occurred, and if we don't have the raw data stored in some layer, we might have to extract it from the source. And the challenge with that is, if the data has got deleted from the source, we will not be able to extract it. If we have data in the bronze layer, and let us assume that the pipeline gets crashed, we can anytime refer to the data which is in bronze layer, and we can replay the pipeline. And that is the reason we have data in bronze layer, and we normally keep it immutable. We don't modify it.
Okay, okay, fine. We'll move to the next question. So, tell me, how do you handle duplicate records and partial files when multiple files arrive for the same day?
If multiple files arrive for the same date, the other metadata of that particular file is going to be different. Based on the metadata, like the last modified timestamp, as well as the name of file, we can judge that for a certain date we have received two files. Then we also need to check the record level duplicates. In PySpark, we have fill NA and drop NA. So we can also fill null values with some dummy values, and we can also drop these values. So with the help of drop NA, it is possible to drop these values. So in PySpark, there are transformations readily available to deal with record level duplicates. So if it is a file level duplicate, we will check it through the file metadata. And if it is a record level duplicate, then we are going to use the PySpark transformations.
Hmm. Okay, so previously you mentioned that in your project you did work on the bronze, silver, and the gold layer. So I'd like to know about what kind of transformations did you perform while moving from bronze layer to silver?
Sure, sure. The data used to be kept in the bronze layer, and that was the completely raw data. What we used to do is to convert that raw data into a data which data analysts and data scientists can analyze and come up with some insights. We had to perform data cleaning, data enrichment, as well as data modeling onto the data which is present onto the bronze layer. And then we used to keep that data onto silver layer. The data which was there onto silver layer, we used to perform the aggregation logic, and that data used to be kept onto the gold layer. So while performing data cleaning, we heavily used deduplication, the drop NA transformation. While checking the data quality rules, we used filter, and we also used case expressions, so that if there is anything like condition based, if we want to make any changes to the data, then we used case expressions as well. While talking about the enrichment part, of course, we went with select EXPR transformation in PySpark. And while we were calculating the aggregates, we went with the group by transformation. We also went for the window operations. And in case of the data modeling part, we have to heavily use the join operations. So these are the common operations which we have used in our project.
Okay, cool. And in all of these actions, how did you handle the schema evolution during ingestion?
Yes, schema evolution was a challenge for us as well, because onto the source level, when the schema changes, the pipeline needs to be modified or updated alongside. And if these schema changes were made without our knowledge, then it can also break our pipeline. And these events have occurred as well in the past. So what we did was we defined the schema initially, and after that, whenever the data arrives, there is a way in Spark using which we can infer the schema of the file or the content which we are able to see. So we used to infer the schema, and we used to match this schema with the schema which we have defined with the schema which we are expecting. And if there was any mismatch, we used to raise the flags. Then we used to deal with the data. Anyways, it was a strict policy that if there is any change in the schema, the data engineering team needs to be notified so that the pipelines can be updated. Regardless, we always got the updates, and as soon as the schema has got changed or evolved, we used to modify the pipelines. That's why the volume of errors associated with the schema evolution was less.
Okay, fine. Moving ahead, I'd like to know how would you design a multi-region or cross-cloud medallion architecture? Since now that we have spoken about bronze, silver layer, and how to move ahead with it, but I'd like to know how would you design a multi-region or a cross-cloud medallion architecture?
Okay, at my current experience level, I didn't had any opportunity to work with designing the medallion architecture. That job is majorly taken care by the architects who have designed the project. My job is mostly around the PySpark part. Like if there are any changes, the tickets will get raised, and those tickets will be allocated to us, and we just resolve those tickets. These tickets are mostly around the processing part. There might be some tickets around the orchestration part as well. But when it comes to architectural level stuff, I'm not currently on a level where I have explored these things yet.
Okay, that's understandable. It's okay, not an issue. Okay, I've understood a little bit about how you've been working on your projects. The next section that I'd like to speak to you about is SQL. Okay,
Sure.
and we'll include some machine test questions as well for you to explain. Okay, so
Sure.
tell me about inner join, left join, and full join, and do explain with examples.
Okay. So is it fine if I can share my screen so I'll be able to explain much better?
Yeah, certainly. Go ahead.
Is it visible now?
Yeah, it is.
Yeah.
Go ahead.
So let me start with the inner join. In case of inner join, if we have two tables, like we have a table called T1 and we have a table called T2. And in case of inner join, what we have to do is we have to pick some joining key based on which these two tables can be joined. And we mentioned the joining condition as well. So in T1 as well as in T2, whenever the joining condition is true, which means the join key which exists in T1, it also exists in T2, then these two records are going to get joined. So all the matching records from T1 and T2 will be there in the output in case of inner join. In case of left join, the records from left table, like if this is the left table and this is going to be the right table, so the records from left table will be joined with the right table. And if there is no matching record, then in front of that record, we will see null values in case of left. So in case of left join, we will get all records of the left table, but we might not get all the records from the right table. We will just get the matching pairs, and if the records from right table are not matched, we'll just get the null values in place of the records of the right table. In case of right join, the scenario is exactly reverse. In case of right join, all records from the right table are going to be visible. All records of the right table are going to be visible, and their respective matching records are also going to be visible. But for the records of right table, if there are no matching records in the left table, we'll be able to see null values. And in case of full join, we'll get to see all the records for a certain keys. And for the keys who don't have matching records either in the left data frame or in the right data frame, we get to see the null values. So these are the join types, I guess. And if you want anything else, or if you want me to dive deeper, please let me know.
I'd like to know about row number. Write an SQL to remove duplicates using row number.
Okay. This query will be removing the duplicates. And in this query, of course, we are deleting the records from the users. And of course, this is the syntax for it.
Okay. Fine. Okay. Write SQL to list customers who did not place any orders.
Okay. So for the customers who have not placed any orders, I will consider two tables. One is the customers table and another one is going to be the orders table. So let me just write the SQL query for it. I think this query is going to resolve our issues. I have considered customers table as well as the orders table and used left join to figure it out.
Okay. What is the difference between group by and partition by?
Okay. In case of group by, we are performing the aggregations. Like, is it fine if I share my screen to explain this topic?
Yeah, no problem. You can use your screen whenever it is comfortable for you to explain your
Sure.
answers.
Sure. Thank you. So when we talk about the group by operation, if let us say I have multiple records with different country codes like India, then US, then again I have records for India, again I have record for US, and I have multiple records. So if I'm talking about the group by operation, so group by operation is going to group all the rows based on the column using which we are performing group by. If I'm performing group by using country code column, it will just create groups of all rows associated with the respective country. Like India and all records of India are going to be in the group. US and all records for US are going to be in a group. Same is the case if there are any other countries and all the rows in this group. Normally, group by is a two-step operation. First, we go for group by, and later we go for aggregation. Let's imagine if I'd like to go for average revenue earned, or total count of records, or the sum of revenue. These kind of use cases are possible through the group by operation. Talking about partition by, the partition by operation is completely different. In case of partition by, of course, the logic is same, but it is not preparing groups. It is just partitioning the records. Like all records of India are going to be, let's say, in a single partition. We can say all records of US might be in a single partition. So respective countries will be stored in a respective logical partition. And of course, these are going to be the full rows, not the groups like we get in the group by operation. The partition by is mostly useful in case of the window operations, where we can perform certain window functions like row number, rank, dense rank on top of these. So according to me, this is the difference between group by and partition by.
Okay. The next question is, how would you find the second highest distinct salary from the employees table?
Sure, sure. Let me just write a SQL query for it. Okay. So this is the query using which we can find the second highest salary.
Okay. Where's okay. Mhm. Find the top 3 highest paid employees in each department.
Sure. Okay. So this SQL query is going to return the top 3 highest paid employees.
Okay. Okay. What is the difference between where and having? How do you use it
Where
in
and
SQL?
having both are going to be checking the conditions in this. So they are going to work on the Boolean data type. However, the where is going to run initially before the aggregation. Let's say in a certain query, if we are working with group by and aggregation, so the where clause is going to get executed before the group by clause, and the having clause is executed after the aggregation has been performed. So this is the major difference between where and having.
Okay. Okay. Fine. Tell me the difference between delete, truncate, and drop.
Sure, sure. Delete is going to be there if I would like to perform some record level deletes or some condition based deletes from a certain table. I can use the delete. If I go for truncate, in that case, all data of the table is going to get truncated, or we can say deleted. In both delete as well as truncate, the table structure is not going to get eliminated. So the table entry is going to be there in the database. But if we go for a drop operation, in that case, the data as well as metadata, it will get deleted. So this is the major difference between these three.
Okay. Okay. Cool. We'll move on to the Python section now,
Sure.
and we'll see your skills in Python and how proficient you are.
Sure.
So we'll start with how to find the duplicate elements in a list. So for example, if there's a given list of integers, and you'll have to find the duplicate values, you can assume the numbers which you'll choose in the list.
Sure, sure. So I have assumed these numbers like 1, 2, 3, like these, and I have written this Python code, and this is going to remove the duplicates from this list.
Okay. But how would you remove the duplicate values from a list while keeping the original order? How would you do that?
Sure, sure. Let me write a Python code for it. I'm considering the exact same list in the previous example. And if we work with this code snippet, it would also preserve the order as we are iterating through the list element and just appending the unique element. It will preserve the order of the list.
Okay. So let's suppose if there are two lists and it have some common elements in between the lists. So how would you find these common elements?
Sure. Let me write a code snippet for it. In this example, I have considered these two lists, A and B. And in order to get the common, I have just removed the duplicates using sets. And after that, I have converted it back to list. And it is going to give me the common elements between both the lists.
Okay. And how would you count the frequency of elements in a list using dictionary? So now we saw here sets. So I'd like to know how would you use dictionary to find the count frequency of elements.
Sure. Let me write a code snippet for it.
Mm-hmm.
So this code snippet is going to give me the frequency. In this case, I'm iterating through the list, and after that, we are just adding up the element as we get one. So if there is no entry, it will just go with 0, and after that, it will incrementally add values if it gets the duplicate record, based on which we can get the frequency.
Mm-hmm. Okay. Okay. And how would you sort a dictionary based on values in ascending order?
Okay, so this is the code snippet which is going to solve the concern which we are facing.
Can you please explain this? How have you used this lambda function?
Sure, sure. See, in this case, what's happening is we have defined a dictionary which currently has 3 elements. So these are 3 key value pairs. What we are doing is we are just calling the items function on the scores dictionary. And in this scores dictionary, I'm going to get list of tuples, which is going to have these elements. And then what we are doing is we are running a lambda function. So this lambda function is going to be applied onto each and every element. And in here, I'm saying x of 1. So if this is the element, in case of scores.items, the A is going to be 0th index and 80 is going to be the first index. So in this case, the lambda function is being pushed through the sorted function, and it will sort the elements by the value which is present onto the first index. So that is what happening over here. And whatever we get, we are converting it to dictionary, and we are printing the sorted dictionary over here.
Mm-hmm. Okay. Now that we're done, with the dictionary, so I'd like to know the difference between list and tuple. At the same time, I want to know the difference between set and list. Do you understand?
Yeah, sure.
Okay.
So let me explain the difference between all 4 data structures which you have mentioned. List or all these data structures are, first of all, collection of elements. In case of list is the collection of elements which might be of same or different data types, and it is going to be mutable, which means we can add, delete, modify elements from the list. And in case of tuple is exactly similar to list, but it is going to be immutable. So we can't make any modifications onto the tuple. Talking about sets, in case of sets, we don't have the concept of indexing and slicing. It is used to perform these set operations like union, intersection, set difference. These operations are applicable onto an element which belongs to the set data type. When it comes to dictionary is also going to be mutable, where we can add, remove data, but it is going to handle the key value pair data. So we are going to have keys and values in the dictionary. We can also have nested keys and values in the dictionary. So that is the main difference between all 4 data structures which you have mentioned.
Okay, but then how will you differentiate between a dictionary and a set?
Sure. Dictionary and set both use curly brace to represent themselves, but in set you get individual elements, and in dictionary we have key value pairs. It differentiates based on the kind of data it holds.
Okay. So tell me, have you worked with data lakes? Do you have experience with data lakes?
Yes. I have worked with the data lakes, and in our project, we have configured data lake using S3 and Glue Catalog.
Okay, yeah, it's the same thing I was actually going to ask you, like what kind of object storage, like S3 or ADLS, and why is it preferred for data lakes?
Sure. Because when it comes to data lakes, we are not looking for a full-time running servers which are going to handle our data like a proper data warehouse. In case of data lakes, we can put data onto the services like S3, ADLS. These are object stores. And in case of, let's say, S3 or AWS, the storage cost is not going to be too high if you compare it with some full-time data warehouse like Redshift. So in case of Redshift, we have to maintain the servers. In case of S3, we just have to pay for the storage. And while configuring the data lake, all we need is the metadata, which can be kept on AWS Glue, so that we can get a data warehouse kind of environment on the data which is currently present onto S3. So we can directly perform queries onto the data which is on S3 if Glue is involved in case of AWS. And in case of, let's say, Databricks, we have the Unity catalog for a similar feature.
Okay, so would you say what you just described is the purpose of Glue Catalog, or let's say Metastore, or would you like to define it further or explain?
Sure. The Glue Catalog is a place where we can define the metadata. And based on the metadata, we can perform the queries. Like if I'm defining a table, then the table name, table properties, columns, the data types of the columns, all of these things would count as the metadata, and the actual data would reside onto S3. So whenever I'm connecting for the sake of queries, I can connect through Athena or Python script, or even through my application to the Glue Catalog and just go for the SQL queries. So the purpose of Glue Catalog is in both ways, actually, in order to access the data in the SQL fashion and in order to maintain the metadata and the metadata versions. That is also one of the purpose of AWS Glue. That too, AWS Glue Catalog.
Okay, so Okay, fine. So tell me, what is partitioning and why is it needed?
Partitioning is a feature which is going to reduce the amount of data which we are trying to process. Is it fine if I share the screen? I'll
Yeah,
explain this
sure. Go
part.
ahead. Please share your screen.
Let's consider we are not going through partitioning and we have the records of different countries like India, US, China. Then let's say again some records from India, some records from US, some records from China. And then I go for a query where I would like to find the maximum revenue for just India. In that case, I'll have to process all of the data from start to end. Let's say if this is a data set of size 10 terabytes, I'll have to go out and process all 10 terabytes of data. But if we define partitions, the data is going to be stored in the respective folders. Like all data of India is going to be in the India partition, or you can call it folder. All data for US is going to be in the US partition, and the data for China is going to be in the China partition. So if in the where clause I have mentioned India, so the query would just get into the India partition and process the data. It will save our trouble to process the data for US as well as China. This is one of the benefit of partitioning, and it is a very powerful feature if used in a accurate way.
Okay. Okay. Good. So moving on, I'd like to know what is Hoodie, Delta, Iceberg, and when do you use upserts?
Sure, sure. The hoodie deltas, or we can say the iceberg. So the hoodie and iceberg have been added so that we can go for the OLTP, like row level inserts, updates, and deletes onto the data which is present onto the object store like S3. And we can also go for upsert operation, upsert, which simply means update plus insert. If we don't have hoodie iceberg in picture, or to be precise, if we don't have hoodie in picture, the upsert operation is going to get complicated because we'll have to manually write the logic for upsert. In case of hoodie, it also maintains the metadata. So upsert operation becomes easier if we are using hoodie.
Okay. And how do you implement cost optimization or choose between Redshift, Snowflake, or BigQuery?
The issue is I'm not say I'm just having 2 years of experience, so I'm not into cost optimizations as well as I'm not into selection of the tools. All I do is I try to implement what has been assigned to my part, but I do have a brief idea on Redshift, Snowflake, and BigQuery. So if we are going with the AWS ecosystem and we want a full-time data warehouse, then we can go for Redshift. And let's say if I want a data warehouse with all the features and integrations, and I'd like to have it open for other features as well, we can go for Snowflake. And if I'm going with the Google's tech stack or Google Cloud stack, then I can go for BigQuery. I might be wrong on this because I have just a high-level idea on these things.
Okay. Okay. Are you familiar with Airflow? You're comfortable?
Yes,
Airflow
I'm quite
orchestration?
comfortable.
Okay.
Yes.
So tell me, what is a DAG in an Airflow?
DAG is directed acyclic graph. We have used Airflow in our project. There are multiple operations which we perform into our project, like we are ingesting data, then we are performing data cleaning and data quality checks. Later, we are writing data onto data warehouse, and we are validating that data if everything is right or not. So there is a sequence of operation which we have to perform repeatedly. So we can automate this with the help of Airflow. We can define each and every step in Airflow as a task, and we can choose the sequence of it. And the sequence of these tasks is nothing but DAG, and it is written in the Python language, and we can submit it, and Airflow can execute these DAGs. So Airflow is not the one who's actually performing any heavy lifting. Airflow is just acting as an orchestrator. It is just triggering the activities which we have to perform.
Okay. So then what would be the difference between a task and a task instance?
Sure. Let's imagine I have defined a task which says print hello. So the definition of task is one thing, and let's say if that task gets executed once, so I will say that is one task instance. If that task executes twice, I will call it two task instances. So the definition of task is called as task, and the number of times the task is getting executed and the time at which this task is getting executed, both things are going to be called as task instances.
Okay. And what happens when a task gets stuck in queued state?
In case of Airflow, if the task is stuck in the queued state, there might be multiple reasons. The very first reason could be that the scheduler might be down. That's why the tasks are not being launched. Another thing, the availability of worker. If the workers are not available, then also the task might be in the queued state. Another thing is if we have configured a pool and all slots of that pool are blocked. So there is no free slot for our task to get launched. In that case as well, the task might get stuck in the queued state. And the kind of executor we are using, like there are different types of executors which we can use with Airflow, like celery executor, local executor, then sequential executor. And if there are too many tasks for the executor to handle, it will be quite difficult, to launch our task right away if there are many waiting tasks. So the issue might lie in executor or the scheduler or the worker configuration or the pool configuration. I will check these four things, and based on that, I will get the appropriate resolution.
Okay, but how will you use retries then? How will you use retries in
Uh,
Airflow?
sure. In Airflow, for a certain task or for the tasks, we can define the retries and the retry duration. Like if a certain task get fails, should we retry, or should we, simply crash the complete thing? So there are two things if we are going to configure the retries. The first thing is retry count and retry duration. How many times we have to try a certain logic, and after how long time. Like if a task gets failed, we are not going for immediate retry, because even if we go for immediate retry, we might have not worked with the actual issue. So we can define the retry duration and retry count for a task in Airflow. That too on a task level when we define it with the help of some operator.
Okay. Tell me, have you had any experience designing a CI/CD pipeline for deploying an Airflow DAG?
Actually, I'm quite interested in CI/CD, and I'm trying to adapt many things, but currently it doesn't fall under my responsibility. It has been taken care by the senior data engineers.
Okay, fine, no problem. Okay, let's keep this interview moving, and we'll go to the next question.
Sure.
So let's say if one source, example, there's an FTP, is delayed, but RDBMS is on time. So do you continue your pipeline, or how would you react?
Sure. If I have multiple sources for my pipeline, and let us assume that if one of the sources getting delayed, in that case, I will first check that if these two sources are required for me in the later stages of the pipeline. If both of the sources, or if the data coming from both of the sources is absolutely required for me for performing the operations, which means the sources are dependent on each other when we are moving into the silver or the gold layer, in that case, I will have to wait for the arrival of data from the another source. But if these two sources are not dependent on each other, I can let the pipeline proceed further.
Okay, and describe to me a situation where your pipeline failed, and how did you fix it? What kind of steps or actions did you take to fix your pipeline?
Yes. Our pipeline has got crashed several times. There were a few reasons behind it. One of the reason was the out of memory error, because we misconfigured the resources. So we diagnosed the issue, root cause analysis was done, and we just changed the configurations of our Spark jobs, and eventually that error got resolved. Another instance where the pipeline was broke was because of the schema which we have received. We were not notified about the change in schema, and the newly updated schema was not going well with our current pipeline, and that is why the pipeline got broke. We diagnosed that issue, then we marked those files as corrupt files, and we just took out what we need for our pipeline from that data. Later, we evolved our pipeline to consider the schema changes which have happened. And the third instance when the pipeline was broke was because of the corrupt data which we received from the FTP source. Because that data, say we used to decompress the data, but the data was not in a proper format. So there was issue initially while the pipeline got executed. So that issue was again diagnosed, and that issue was also resolved. But yes, of course, the pipeline has got broken several times. I might not be able to tell you all the instances, but yeah, these 2 to 3 instances were quite major, which stuck to my mind.
Okay, fine. Thank you, Sandeep. So your interview was fine. We'll proceed further with your processing and get back to you shortly.
Sure.
In the meantime, if you'd like to ask any questions, please do go ahead.
Yes, I have just one question. If I ever get an opportunity to work with you, what kind of tech stack and project architecture I might be working on?
Okay, so the tech stack that we are currently working on is the Azure Data Engineering tech stack, and the architecture which we use in our projects is the Lakehouse architecture. So
Sure,
if
that
you
sounds
get
great.
selected, you'll be working on it.
Yeah, I'm looking forward for this opportunity.
Certainly. Okay, fine. Thank you, Sandeep. We'll talk soon.
Welcome.
Bye.